Oh, it started. Yay, you got to see my face. Hey guys. Hello. I'm here on a Saturday. I decided to come in here because then I could record and you could see my face and you could see that there's no one here. Even if it was Monday to Friday, there's no one here. And I don't think you can see it, but I have not raced the boards because I can't bring myself to race those boards. And they say, it is Bryce's birthday with Jake's Really Bad Wise. Still there. I don't think you can see it though. Oh, it's so sad. Anyways, I miss you guys, and I thought perhaps I would teach today's class like a reverse class. So you're going to see what that means. Okay, so it's going to be a reverse class here. Okay? So we're starting off with limits at infinity. Limits at infinity. And we're going to do limits as x approaches infinity instead of a number like we were doing before, or negative infinity. And the reason why the infinity matters is because that's going to be for every value. Chloe, stop talking. So I know you like talking so much. Stop talking. Lucas, thank you for paying attention. Perfect. Always on task, okay? And Nicole and Claire, if you guys could open your books up, that would be great, okay? Yeah, good job, Lucas. You're always on task. Perfect. Okay, gave you 2. Awesome. Okay. So, no, not right now. Not right now. You can't answer all the questions, okay? Oh, Kaylin, I know you always want to answer all the questions, but you're not allowed to right now. All right? Okay, everyone. I'm glad. Okay, good. Okay, so we have limits as x approaches infinity of f of x and negative infinity. So we're going to look at what happens when x values get very large or very small, okay? All right. Okay, so our investigation. What happens when we look at 1 over x to the r as x approaches infinity? So if I go 1 over x to the r, okay? R could be any value, okay? Let's pretend r is 2. So I'm going to do 1 over x squared, okay? And as my x values approach infinity, let's see what happens. So I'm going to type that into my calculator. Oh, I thought I had brought it up. I did not. 1 second. Matthew, stop talking. You always talk so much. Stop talking, okay? I'm just trying to get the calculator here. Okay. All right. Yes, calculator showing up. Oh, awesome. All right. Let's do this. So, close. If I go y equals, let's say 1 over x squared. Make it look alpha y equals. So 1 over x squared. Okay, and I press my table of values. As my x gets really big, so now as x, if I put a 5 in, I'm going to get 0.04. If I put a 8 in, I get 0.01. What if I put in an x value of 10? So I'm getting bigger. 1 over 100. Well, that's 1 over 100 is 0.001, right? If I do second trace value, say I put in 10,000. I'm exceeding the limit. Why? Because, oops, as I go to my table of values, as my x's get bigger, look what happens. I just get closer and closer to what? To 0, right? I'm just getting closer and closer to 0. What happens if I, instead of having x squared, I have 1 over x to the 7? What happens if I have that? If I have 1 over x to the 7, it's actually approaching 0 faster, right? So, if I have the limit as x approaches infinity of 1 over x squared, whenever I put in any values here, say I put in 10, I'm going to get 1 over 100. Say I put in 100, I'm going to get 1 over 1,000, so 10,000, right? So I get faster and faster to 0. So as I approach infinity of 1 over x squared, x cubed, x7, or even if this is a 2 over x squared, or a 3 over x squared, or a 4 over x squared, as x approaches infinity and gets larger and larger and larger, my answer is going to get closer and closer and closer to 0. If I do negative infinity, so let's put that x squared back in. And this time I'm going to go, so I said x7, which just gets there faster. I'm back in my x squared. And I'm going to go to my table of values, and I'm going to go to my negatives. What am I getting closer and closer to again? 0, right? Because as I approach x squared, this is going to become a number. So I'm going to get closer and closer to 0. Okay? So, where r is a positive rational number, when you have the limit as x approaches infinity of 1 over x to the r, whatever r may be, or this could be 3 over x to the r, or 100 over x to the r, it's going to keep getting closer and closer to 0. And the limit as x approaches negative infinity of 1 over x to the r equals 0. Oh, Jacob, stop doing English right now. I know you love English so much. I know calculus isn't your thing, but you just have to stop doing English, okay? Stop it. No more English today, all right? Okay, Ben and Mason, you guys need to get out some books. Like, you're never paying attention. This is not okay, all right? Gabe and Lucas, fantastic, right on board. Jacob, you never have any. Jake, you never have any questions. Just doing great. It's great. Okay, good, clear. All right. Let's look at this. If R is a positive rational number, as I approach infinity of any number C, if C is a real number, so 10, 20, 30, 40, wherever that little number is up there, it's going to equal 0. And the same thing as I approach negative infinity, it's going to equal 0. So there's your notes. So if we're asked to evaluate the limit of the following, okay, when it's a polynomial over a polynomial, the steps that you're going to do in order to do this is you're actually going to divide every term by the largest exponent variable, okay? That's the first step you're going to do. You're going to divide. So when you have a polynomial divided by a polynomial, you're going to divide every term by the largest variable exponent. And why are we allowed to do that? We're allowed to do that whenever we have a variable, any type of terms, we can divide everything by the same thing and it doesn't change it. So but you just have to do it to every single term. So our largest exponent right now is x to the 4. So my first step is going to be rewrite the limit because I haven't used it yet. Remember, it only goes away once you've used it. So limit is x approaches infinity. And now I'm going to go 2x to the 4. The largest exponent is actually x to the 4 in both the numerator and the denominator. And I have to choose the largest one. So that is the largest one. So I'm going to divide by x to the 4. Then minus x squared divided by x to the 4. Then plus 8x divided by x to the 4. And then I'm going to go all over negative 5x to the 4 over x to the 4 plus 7 over x to the 4. Step 2 is to reduce. So I'm going to go back over here and I'm going to rewrite my limit out. The limit as x approaches infinity. So the x to the 4's cancel. This x squared cancels and becomes a 1. This becomes a 2. This becomes like a complete 1, right? Remember whenever we cancel, they turn into 1s? And then this x cancels off one of those, so it's x to the 3. X to the 4's cancel. So I'm left with 2 over nothing. So I'm just going to write it as a 2. Oh no, touched the wrong thing. Bryce, you can't be mean to people. Stop being mean to people, okay? You know, you have to be nice every so often, okay? All right. So we have 2 minus 1 over x squared plus 8 over x cubed over negative 5 plus 7 over x to the 4. All right. Now, I told you, whenever you take the limit of anything with a number over an x squared or a number over an x cubed or a number over an x to the 4, if you take the limit as x approaches infinity of those, they become 0. So when I apply that to the 2, 2 just stays at 2. When I apply it to the negative 1 over x squared, that becomes minus 0. This is going to turn into a 0, right? When I apply the limit to it. We just said that. That's the rule up here. Then I have 8 over x cubed. When I apply that to infinity, that's going to also approach 0. I'm going to be left with a negative 5 on the bottom. And then plus 7 over x4, that's going to become a plus 0. So my actual answer is negative 2 over 5. Which is over here. And remember the rule about rationals? When I wanted to find the asymptote, that horizontal asymptote, which is what we're actually finding right now, if they were the same degree, I just took a fraction of the coefficients. Look, it worked. Lucas, could you get Agatha on task, please? Thanks. Okay. All right. Now, as we approach negative infinity of a polynomial over a polynomial, we do the same thing. It doesn't change. Exact same steps. So, they're actually both x to the 4. So we're going to do the exact same steps as we just did. It's the exact same question. It's just to negative infinity, which actually doesn't change it when it's a polynomial over a polynomial. So we're going to get 2 x to the 4 over x to the 4 minus x squared over x to the 4 plus 8x over x to the 4 over negative 5x4 over x to the 4 plus 7 over x to the 4. Once again, they cancel just like we did. Exact same steps. And in my next step, when I apply my negative infinity to the number 2, I keep a 2. Negative infinity to 1 over x squared becomes minus 0. Negative infinity to 8 over x cubed becomes plus 0. So these are going to turn into zeros once I apply the infinity. Not actually in this blue step, but in the next step they become zeros. But I'm just showing you. Those are going to all become zeros, right? So this red step doesn't happen till you apply the infinity. Negative 5 will stay a negative 5 and then a plus 0. So I get negative 2 over 5. Now we're actually going to look at this graph. We're going to type it into our y equals. So go ahead and do that. Just into your y equals the actual graph. The whole thing. So I'm going to go alpha y equals, enter to get my fraction. And then I'm going to go 2x to the 4 minus x squared plus 8x over, oh no, I put it in the exponent. Try again. 2x to the 4 over minus x squared and then plus 8x all over negative 5x to the 4, arrow over, plus 7. And I'm going to go zoom 6, get my standard window. Does my horizontal asymptote look like it's possibly at negative 2/5? I think so. So could you just tell it off your calculator? No, that's why you need to know your limit rules. And when we gave you the rules in rationals in 30-1, if the numerator is the same degree as the denominator, the horizontal asymptote, where it ends, see look, positive infinity, where is it ending? At negative 2/5. As I approach negative infinity with my x, where is it ending? Negative 2/5. So with polynomials in the numerator and the denominator, you have a rational. And your end, your infinity, and your positive infinity and negative infinity are going to actually approach the exact same horizontal asymptote. And that's why we could use the rule that if the numerator is the same degree as the denominator, you got the same answer. One thing I want to extend on this. So say I gave you the limit as x approached infinity of 2x over x squared minus 3. Okay? I still have to divide by the largest exponent. So my largest exponent is x squared, and I have to do it to every term. So I'm going to get 2 over x squared over x squared over x squared minus 3 over x squared. This is going to become a 1. So I'm going to get the limit as x approaches infinity of 2 over x squared over 1 minus 3 over x squared. And remember when I I had a polynomial over a polynomial. I had like a linear over a quadratic, so polynomial over polynomial. But the infinity and negative infinity are actually going to get you the same answer. So if I did negative infinity, it's still going to work. Remember, when I apply infinity to this is going to actually become 0, 2 over x squared. The 1's going to stay a 1, and the negative 3x squared is going to, 3 over x squared is going to become 0 as well. So my answer is actually going to be 0 over 1 minus 0, which is 0. So technically, as I approach infinity, I'm telling my horizontal asymptote of this is 0, which, what did I tell you in 30-1? If the numerator is a smaller degree than the denominator, your horizontal asymptote is always y equals 0. Look, this is why. It's because you're going to divide by the largest exponent, and that numerator is actually going to become 0 because it doesn't have the largest exponent on it. You're all probably freaking out right now because I just noticed I forgot the x. So this would still be here as 2 over x. Still going to turn into a 0. Don't freak out, because 2 over x still becomes 0. So it'd be equal to 0, okay? Okay. Quit and stop talking. Yeah, out of control. Parker, you've been so good. Such a good kid, you know, paying attention. You haven't left the room to go to the bathroom or anything. Just being great. Ed, I'm so glad you brought Ella in again. That's not backwards. I really do miss Ella. She's such a good dog. Okay, good. So this is what we have to do if we have a polynomial over a polynomial. All right. So, Matthew, you can ask all your questions later. I'll help you out later. Okay. This one, still infinity. What's the difference though? There's a square root, a radical in the numerator. So this isn't a polynomial over a polynomial. When you have radicals in the numerator, you actually have to check your signs. Okay? How you're going to end up. So let's just, first thing we're going to do before we divide by our largest exponent, which we're still going to do, is we're going to check if we plug in a really large number, what sign am I going to end up with my answer? Negative or positive? So let's plug in 100. If I plug 100 into the top, no matter what, this top is going to have to be positive because I can't take the square root of a negative number. So I'm going to end up with a positive sign on the top. On the bottom, if I put in a really large number, 5 minus 2 times 100, I'm going to end up with a 5 minus 200. So no matter what large number I put in, I'm going to end up with a negative on the bottom. The top, I have to have a positive because you can't take the square root of a negative number. And the bottom, I'm going to actually end up with a negative. So no matter what, my answer is going to end up being negative in the end. We just need to keep that in mind. So when we have that radical, we have to check by putting in a really large number what sign I'm going to end up with. Because the number is going to be the same for both of them, but the sign for when you approach negative infinity and positive infinity, but the sign will be different. Okay? So the largest exponent I have in the bottom is an x, and in the top I have an x squared. Okay? Now, this is what throws people off. I'm actually going to divide them all by x. Now, people are like, that doesn't work. The largest exponent is an x squared. Actually, on the top, I have a 3 square root of x squared. And what's the square root of x squared? Square root of x squared is an x. So if I actually take the entire square root and I divide it by x squareds, it's the same as if I divide the entire bottom by x, because I'm actually dividing them both by x indirectly. Because the square root of x squared is x, and I have an x in the bottom. So I'm going to divide all the tops by x squared, because that's the same as dividing the bottom by x, because the square root of x squared is x, the bottom has an x. So the first step is to divide by the largest exponent, which happens to be x in both cases, in the numerator and the denominator, but under the radical, it shows up as an x squared. So I have the square root up here, big square root, and I'm going to have 3x squared divided by x squared, plus 6 divided by x squared, which is like dividing by x outside of the radical. And in the bottom, I'm going to have 5 over x minus 2x over x. I'm actually technically dividing them all by x, because the square root of x squared is x. I'm just leaving them under the square root. Now the x squareds cancel, and the x's cancel. Okay? When I apply this to the inside, I'm going to get the limit as x approaches infinity of the square root of 3 plus 6 over x squared all over 5 over x minus 2, right? Now, when I apply infinity to the inside, this is still going to become a 0, and so is this. So my answer is going to be square root of 3 over negative 2, which actually worked out. Sometimes, though, the sign is actually not correct, so you always have to check for your sign first, okay? As in, example, the bottom. So we're actually going to do the exact same steps, right? Exact same steps are going to get me square root 3 over negative 2, we agree? However, the answer is in brackets over here. It's positive. Why? Because I should have checked. I would do all these exact same steps to get me this with negative infinity. I just have to check in the end. So right away off the bat, I have to make sure I'm holding the right sign. So once again, if I plug in a really large negative number into here, I'm still going to get a positive. And I need to get a positive because I can't take the square root of a negative. If I plug a really large negative into the denominator, though, I'm going to say, let's say I plug in negative 100. I know it's not a really large negative, but it's a negative enough to show you. Negative 2 times negative 100, no matter what negative really large you fill in, this is going to become a positive number. It's going to become 5 plus 200, which is 205. So I'm going to end up with a positive over a positive. So my answer is actually going to become positive. I don't have this sign here. Because as I plug in those really large negatives into here, this negative 2 is going to become positive. So if I went to go show the actual steps for this one, this is what I would do. I would go limit as x approaches negative infinity, and then I'm going to get 3x squared divided by x squared plus 6 over x squared over 5 over x minus 2 over x, because that's like dividing them all by x, remember? 2x divided by x, so I did it again. These cancel. Okay. Now, I'm going to end up with the limit as x approaches infinity, 3 plus 6 over x squared all over 5 over x minus 2. Okay. The catch is when and this is a negative infinity. When I approach this with negative infinity, this will become a 0, this will become a 0, and this actually becomes a positive. And way back here, it would have became a positive. Because as I approach negative infinity, this number, this x before it cancels off, so I'll show you where I am. This x here before it cancels off, when I put in negative infinity, would actually turn this to a plus sign. And so I end up with square root 3 over 2 positive. Now, we can plug it in and check, just like we did the last one. So go to your calculator, and we're going to plug in the original. And we're going to look at negative infinity x and positive infinity x to help us out. All right. So I'm going to type it in. I went to go write it in. That wouldn't have worked. So I'm going to get alpha y equals enter to get my fraction. And then I'm going to go square root 3x squared plus 6 over 5 minus 2x. Graph. Okay? Look it. As I approach negative infinity, it's approaching positive root 3 over 2. Obviously, you would never get the root 3 over 2 unless you did the actual math. Positive root 3 over 2. And as I approach negative infinity, so I'm going to make this window larger, or positive infinity, so I'm going to make this window larger, like 50 for my x max. As I'm approaching positive infinity, I'm getting closer and closer to negative root 3 over 2. So you can use your calculator to check your answers too. Approach the very farthest left, x. Approach the very farthest right, x, and see what horizontal asymptotes you're going to get. That's the end of that lesson.